All right, so this lesson's on rational exponents, and we have worked on exponents quite a bit, so this is the new part, is the rational part. So we need to remember those properties of exponents that we've done. For example, if I have a to the fifth times a to the fourth, so notice my bases have to be the same, but then that equals a to the 5 plus 4. We add our exponents to the ninth. Same with numbers. 2 to the third times 2 to the fifth would equal 2 to the eighth, and then we'd solve that out. And remember our power to power rule. So if I had 2 cubed to the fifth power, that would equal 2 to the 3 times 5. So we multiply there. Same with variables, same rule. If I had v to the 6th to the third, so v to the 6th power cubed would equal v to the 18th. So remember that rule. And then also your negative exponents. So if I had c to the negative 5, that would equal 1 over c to the 5. So this does not mean that the c is negative. It means that we are dividing by the c to the 5th. So those properties we've used before. We want to make sure we remember those. But today we're going to use what's called rational exponents. Remember, rational is kind of another word for fraction. That fraction, we don't usually include variables, and a rational can do that. So our first thing is that we're going to be able to write rational exponents into radical form, and things that are in radical form into rational. So we can use both methods because we know how to solve things with exponents, and now we can looking at solving things with radicals and how those relate, and then some simplifying. So here's our first definition, that anything, if I have a base b to the 1/nth power, that equals the nth root of b. So notice that denominator became my index. So a to the 1/7 would equal the 7th root of a. W is the square root, and we need to go the other direction, so we know our index is 2 if there's not one written there, so this would equal w to the 1/2. And 1 because our exponent is 1. So if I had so this would be the cubed root of a, and this would be x to the 1/5. Now, we've looked at those, and notice all of those had, so if I had a to the 1/5, that was the 5th root of a. And my power of my a is 1. So what if that power isn't 1? So what if we have a number on both, not the one on top? Well, that is our power, and then the denominator, the numerator is our power, and the denominator is our index. And you can write it a few ways. Like I can write this as the cubed root of 27 squared, or I could put the squared in here. Normally we'd put it on the outside because that has us dealing with a smaller number. We know what the cubed root of 27 is, so then we can just square that. So this, we have that negative exponent that we talked about at the beginning, so that means that we need to change that to 1 over 49 to the 1/2, and 1 square root of 49 would equal 1/7. So here we'd go 32, 5th root, and whatever we get there, we're going to square it. So the 2 here, and the 5th root. So we know the 5th root of 32 is 2 squared. And remember, we know that because if we factor that out, we see that 32 is 2 to the 5th power. So those would square out. Or so the 2 would come out of the radical. And then we'd go ahead and square it and we give 4. One thing that I wanted to mention and that you'll see on your worksheet, so if I had the cubed root of 4, a to the 6, b squared, c, so we've looked at this, we need to be able also to go backwards just like we did in the beginning. So if I want to write this into a rational exponential form, I would write it as 4 to the 1/3 because we have our product property, remember? We can take the cubed root of each one of them. A to the 6/3, b to the 2/3, and c to the 1/3. So we kind of already knew we'd divide those, but now we can see what happens if they don't work out. So I want to simplify that. 4 to the 1/2, a squared, b to the 2/3, c to the 1/3. And that would be that in exponential form. Then I go past these and look for the last part here. So they were just plugging in to 168 in to get our amount. So same rules with rational exponents as with non-rational exponents. You're going to take this and go 1/7 plus 4/7. And if I can reduce, I want to reduce y to the 5/7. So this would be x to the 3/5. All right, thank you. If you have any questions, make sure you come in.